Hi, hello everybody. My name is Estefany Aguilar. I'm front-end developer and illustrator. I'm from Medellin, Colombia, and this is my first time in Berlin. I love sharing and learning new information about technology, and the Colombian tech communities have been a source of inspiration for me. In Colombia, we have about 19 tech communities providing spaces for innovation and collaborative learning. In Medellin, I'm one of 3 leaders of Medellin CSS community, the first and only CSS community in my country, a community with more than 1,000 members, a community that creates positive change and educates for the future. Today, I'm going to talk about CSS logical properties. In CSS, we have a lot of keywords to describe physical positions, such as left, right, top, and bottom. Let's take this image for example. If we want to move an element of the screen, we will use a container with a relative position, the element with absolute position, top 50 pixels, and right 50 pixels. But of course, moving an element is not the only thing that we want to do. We also need to work with other physical properties, such as margin top, border bottom, padding left. These properties come naturally if we are working in an English grading system. For us, the origin in our web page is top left because we grade from left to right. But have you ever thought how our layout would look in a different grading system, in a different alphabet? For example, in Arabic, Hebrew, and Persian, they grade from right to left, and the origin of their screen is top right. So, what you will see on the left side on the English grading mode, you will see on the right side in an Arabic, Hebrew, and Persian grading systems. Consequently, working with physical properties can become a problem if we want our layout to work in many languages. I just mentioned the words grading modes, but I want us to look at how this specification works and what we can gain from it. These grading modes can help us better understand CSS, Grid, Flexbox, and the work involved in creating a web page in a new language. The grading mode affects both the organization and directionality in our web page. So, the grading mode is the first building block of each design that we create. CSS is able to support many different international grading systems. Systems that grade from left to right, such as the Latins. This is the most commonly used grading systems around the world, with more than 2,500 million users. Systems that grade from left to right, such as the Arabic grading systems. This is the second most commonly used grading systems around the world. It is used in many languages around the Middle East, Asia, and Africa. Systems that are bidirectional. These are a combination of Latins and Arabic alphabets. Systems that are verticals, such as Asian characters. Because CSS supports all these many languages, there are 5 possible grading mode options: horizontal TP, vertical LR, vertical RL, sideways LR, and sideways RL. A grading mode in CSS is determined by the properties of grading mode, direction, and text orientation. It is mainly defined in terms of block flow direction and inline-based direction. So, let's look at it in CSS words. If you have worked with CSS before, you might be familiar with display block and display inline. If we are in a default grading mode, we will see that by using display block, all the elements are placed vertically from the top of the page to the bottom. But if we use display inline, we will see that the elements are placed side by side from left to right. This is the inline-based direction, which indicates how we read and write. Both block and inline concepts will help us understand CSS logical properties ahead. Let's take a look at some examples for different values. Grading mode, horizontal TB. Horizontal TB is the initial value. the text is displayed from left to right, with a block flow direction from top to bottom. Both the grading mode and the typography mode are horizontal. Grading mode, vertical RL. The text is displayed from top to bottom, with a block flow direction from right to left. Both the grading mode and the typography mode are vertical. Grading mode, vertical LR. The text is displayed from top to bottom, with a block flow direction from left to right. Both the grading mode and the typography mode are vertical. Grading mode, sideways RL. The text is displayed from top to bottom, with a block flow direction from right to left. The grading mode is vertical, but the typography mode and the symbols are placed on the right side. Grading mode, sideways LR. The text is displayed from bottom to top, with a block flow direction from left to right. The grading mode is vertical, but the typography mode and symbols are placed on the left side. It's important to consider the compatibility between grading mode and browsers. In this table from Can I Use, we can see which browsers are compatible with grading mode property. Everything shown in green is the supported version. But in some versions of Chrome, Safari, Opera, the color red indicates it is not supported yet. Another consideration is that some versions need a prefix, like WebKit or MS, to be able to use grading mode property. And you can look up here in this upper right hand, where it says global in May 2019 is 97.16%. That's great. Another important property of grading mode is direction. The direction property defines how inline content, such as the characters in a paragraph, flow on the screen. It can have two values. Left to right is the first one, and the other one is right to left. CSS logical properties automatically map layouts to the content direction, set with the direction and the grading mode properties. Before, we use physical position to build layouts. But more recently, we have started using a new approach to building layouts: Flexbox and CSS Grid. Let's take a deeper look into Flexbox and the logic involved. Flexbox doesn't take into account physical dimensions, such as left, right, top, and bottom. It uses values like flex start and flex end. These values rely on the direction of the main and cross axis, which we use in Flexbox. This is better because concepts like start and end are relative in Flexbox and can be easily flipped. Here, we have an example of Flexbox in action. The first thing that you need to do to create this example is define the container we display flex. By default, all the elements are placed side by side from left to right. If we need the elements to be placed vertically, we need to add another property to the container: flex direction. We need to keep in mind that Flexbox is a single direction layout concept. That is, the elements can be placed in horizontal rows or vertical columns. For this reason, flex direction has 4 different values. Row. Row is the default value and depends on the direction of the grading mode property. If you are in an LTR direction, you can see that the elements are placed side by side from left to right. But if you are in an RTI direction, you can see the elements are placed from right to left. Row reverse is the same concept like rows, but in this case, if you are in an LTR direction, you can see the elements are placed side by side from right to left. And if you are in an RTL direction, you can see the elements are placed side by side from left to right. Column is the same concept like row, but in this case, the elements are placed top to bottom. And column reverse is the same that row reverse, but in this case, the elements are placed to bottom to top. With only these two properties, display flex and flex direction, we can see the magic in this example. When the bottoms change to the values of the gradient mode property in horizontal TB, vertical LR, and vertical RL. In Flexbox, the behavior of the lines depend on the flex direction property. For example, justify content aligns the elements. Horizontally, if flex direction is row or row reverse, but vertically, if the flow direction is column or column reverse. This is the real beauty of Flexbox, and this is the beginning of the logic concepts in our layout. Justify content property can be take 5 values: flex start, flex end, center, space between, and space around. But let's focus on the first two, flex start and flex end. In this example, you can see that the start and end concepts change depending on the gradient mode property. After Flexbox, the most powerful layout systems appear: CSS Grid. CSS Grid is a two-dimensional system created specifically to solve the layouts problem we have been hacking from a long time. CSS Grid doesn't know left, right, top, and bottom properties. Basically, CSS Grid flows the same logic as Flexbox. You can define the position of the grid items with properties such as grid row start or grid column end. Similarly to Flexbox, CSS Grid also has logical properties instead of physical ones. Let's take a look at one example. To get started, you have defined the container with display grid. The elements with also for coordinate the elements, you need the container defined with grid template columns or grid template rows. To place the children into the grid, we need to define each element with grid column start 1, grid column end 2, grid row start 1, and grid row end 2. Or use a shorthand like grid row start / end, grid row start end. The way of thinking in CSS logical properties. A very important theme in CSS is the box model. We are use the box model shown on the left side of the screen. This is not wrong. This is still correct. But in order to use the CSS logical property, we must stop thinking in terms of left, right, top, and bottom, and replace them with inline start, inline end, block start, and block end. You can see this change in language shown in the second box model. Now, we return to these two concepts, block and start, and inline. When we work with logical properties, we start understand the block and inline axis. As we shift to this way of thinking of our layout begins to make more sense. Now, our logical properties will be like the list shown on the left. Margins. On the left of this table, you can see the name of the property, of the physical property. Margin top, margin left, margin right, and margin bottom. And in the right side, you can see the equivalent of this physical property. For example, of margin top, the equivalent is margin block start in a logical property. At the same, in margin right, the equivalent is margin inline end. This is an example of margins. In this case, I use margin block start property. And we can see how it changed when gradient mode property change. You will want to keep your eyes on the space between the first block and the second block. This is the margin block. Paddings. This is the same of margins. On the left side, you can see the properties, the physical properties, such as padding top, padding left, padding right, and padding bottom. On the right side, you can see the logical property, the equivalent logical property, such as padding block start, padding inline start, padding inline end, and padding block end. Here, there are some examples for paddings. Again, you can see how paddings change when the gradient mode changes. The container here is showing dark purple, and the child is represented with the border in color white. The dark purple outside of the white dots is the padding. Borders. In this table, you can see at the left side the physical properties. This is a little bit complex because it's the border, top, and you can place the size or style or color. And the same, the logical property, the logical equivalent property is border block start, and you can set the size, style, or color. This example of borders might be a little more complicated. The different colors of the border shown here will help you track how they change differently. With the red border, I use the border inline start property. For the purple border, I use the border inline start property. And the other block, with yellow border, I use the border block end. Positions. On the left, you see the name of the property as use of the old box model, top, left, right, and bottom. On the left side, you can see the logical property equivalent, like inset block start, inset inline start, inset inline end, or inset block end. Just like gradient mode, the compatibility is important. And again, some versions need a prefix. And you can see on this upper right hand when say global is 92.49%. In conclusion, we need to think in ways of create web page that are accessible to everyone. Thinking in terms of logical properties is a good practice when creating a web page with multiple languages. But okay, I have a little quiz for you. Please take out your phone and write kahoot.it. Okay, in your phone, you can see a text game pin. Here, you put the code. Yes. Okay, this is the code. Has everybody joined the game? Okay, let's start. Okay. CSS logical properties. The first question, which is the first building block of each design that we create? Whoa. The next. Okay. Which concepts help us understand the CSS logical properties? What is the logical property equivalent to the margin top physical property? Whoa. What is the logical property equivalent to the padding left physical property? I don't know what is the name. Okay, the last question. Thinking in terms of logical properties is a good practice when creating a web page with Whoa. Okay, the winners, please find me during the coffee break, please. I have a little gift for you. Colombian candies. And okay. Everybody, I have stickers for you. Don't worry. And I have a great news. We have a new member of the CSSconf family, CSSconf Colombia. And I'm one of the leaders of the CSSconf Colombia. I'm very, very excited to host this conference in Medellin the next year. And thank you. Find me on social media at DevCode.